Now it's time for linear inequalities in one variable. The average daily high temperature in Santa Fe, New Mexico over the course of 3 days exceeded 75. Given that the high on the first day was 72 and the high on the third day was 77, what was the minimum high temperature on the second day? Okay, so the first thing is you need to understand what an average is. The average daily high temperature. That means you add them up, and this was over 3 days. So in that case, you would divide by 3. So you would say day 1 plus day 2, but day 2 is what we don't know, plus day 3, which is 77. To find their average, you would divide it by 3, because there are 3 temperatures. And it said that this average exceeded 75. What's that mean? Exceeded 75. That means it is more than 75 degrees. So to find out what that second temperature was, the minimum that it could be, we just need to solve this equation. So let's go ahead and multiply everything by 3. We'll have 72 plus 77 is going to be 149. So the 3's, when we multiply this one, the 3's reduce to 1. So that's greater than 75 times 3 will give us 225. Now we just need to subtract 149 from both sides. This is 0, so x had to be greater than something. It had to be greater than 76 for that average to be more than 75. So 76 degrees was the minimum temperature for day 2. A test for quality at a plant manufacturing silicon wafers for computer chips, a random sample of 10 batches of 1,000 wafers each must not detect more than 5 defective wafers per batch on average. Holy moly, that didn't make a lot of sense, did it? In the first 9 batches tested, the average number of defective wafers per batch is found to be 4.78. What is the maximum number of defective wafers that can be found in the 10th batch for the plant to pass the quality test? Okay, so they can't have more than 5, so it's 5 or less, right? Okay, so we know that something is less than or equal to 5 because that's what we want to happen. Well, we're working with an average again, and we're looking at 10 batches, so we know we have to add up 10 things and divide by 10. Now let's see what else we have. The first 9 batches, there were 4.78 per batch. Let me make this a little bit longer. So that would be 9 times 4.78. That would tell us how many were defective in the first 9 batches. But we don't know how many can be defective in the last one. Okay, so that's how we would figure that one out. So multiply 9 times 4.78. And we get 43.02 plus x. Now I want to go ahead in the same step and multiply everything by 10. So when we multiply this one, we just get the numerator. That's less than or equal to 5 times 10 will give us 50. We need to subtract this 43.02. So this is 0. X must be less than or equal to 6.98. So in that last batch, they can only have 6.98 defective wafers to pass the quality inspection.